Now, what does this stuff cost? And the conventional wisdom was in our subcommittee when we first started that it wasn't significant. It was, at home, I had one put in for $2,500. It's a 240 volt level 2 unit, so it didn't seem that significant. And then we started looking at level 3. Level 3 is getting to be a little bit on the pricey side, and making the business case for doing that is, can be a challenge. So a few of us in the committee started raising the issue, should we be using these numbers from the DOE or should we generate our own numbers? So we went ahead and actually commissioned a study which my firm did, and that's what I'm going to report on in the remaining slides. This is a building that exists in downtown Boulder, Colorado. It's a bus facility with parking, and it's also used for parking for both commuters and downtown Boulder shoppers. And our study took a look at this question: what if we were to convert this existing building to EV charging? So we did 25, 50, 75% of the 300 parking spaces. And then within that, we said, let's make 90% of those level 2, in other words, 240 volt, and put a few in there. 10% of these parking spaces were going to be DC fast charging, just to get an idea of what the cost of these systems would be at different penetration levels. This is what the chargers look like today that you can buy. The 240 volt charger with the J plug is something, this happens to be an Eaton product, and AeroVironment makes a 480 volt charger. So that's the kind of real hardware that we sought quotes on, okay? Now, we decided to actually get formal bids on doing this work, because there's nothing like a bid from a contractor to solidify and give a concrete anchor to what you're talking about. So we wrote a performance spec. The engineer, it's a 45-page standard document that you would use to get any kind of electrical work done. A set of a dozen drawings was made for the various penetration levels and so forth. So it was a real design. Now, in the course of doing the design, we found that the code itself, the National Electrical Code, which every design must conform to, doesn't address EVSEs. However, it doesn't prohibit them. And I'll make a point later about what the effect or what changes in the code might be useful. But it's not a major problem. Now, what we found also was when the local utility heard about this study that we were doing, they immediately thought we were going to actually do this work, and they went ballistic, because the electrical loads on a level 3 charging are just huge. And we're talking about new service to the building, we're talking about new switchgear, we're talking about a tremendous amount of investment, and the case isn't out there for who pays for this. In other words, does the utility put it in and put it in their rate base and come up with an EVSE charging rate? Or how does this happen? The city happens to own this building, so it could be that they get into the business, but in Colorado they can't sell power. So it's kind of tricky. And remember that, just to repeat, that the number of high level 3 charging stations in this building was small. It was even under the 75% parking space penetration level, it was a couple dozen units, okay? So this is the cost curve. And basically, the way you read this is across the bottom. That would be the 25%, the 50%, and the 75% of those 300 parking spaces were equipped, retrofitting EVSE charging facilities for that number of vehicles. And the 3 lines, oddly enough, are 3 different contractors' bids. These guys didn't talk with each other. They thought they were working on an actual design that would be installed, and they're within 10% of each other. 3 guys, all Denver, real electric contractors, and their bids generated independently were within 10%. So that gives us some confidence in the numbers we're talking about. So the cost curves can be used to generate the per unit cost. And you see that across the bottom. So to put in this parking structure a level 2 EVSE cost you $12,000. Now that 12,000 is 5 or 6 times greater than what the committee had been using previously for its electric charging, again, in the commercial setting, in a retrofit building. Now this is the serious cost right here. This is level 3. And again, you see the 3 different points across the bottom. And you see the significant cost that was involved in this installation. So, I mean, this is really mind-boggling to think that to put a DC charging in a quick charger is $100,000. But these are bids, these are quotes, we can't argue with them. That's 3 times the cost of the electric vehicle itself. So the point is that people can talk about fast charging, excuse me, but making the case for that is not so easy. This is a significant investment. Who's going to pay for it? Okay? So we learned a few things from the study. And one of the things that the National Electrical Code requires is that you put in enough service for all these charging stations to run at the same time. And in actual practice, that should be tempered to some extent by what we call diversity. In other words, not every unit is going to be plugged in running at its capacity all the time. And the code has methods of dealing with diversity, so we can take a look at that and hopefully reduce the charge for the installation. Now, we haven't done any detailed work on how to do intelligent or semi-intelligent charging. We've equipped each one of these stations with IP addressability functions, but how does that work? It's not a big deal cost-wise. We were mostly looking at the cost, so we've equipped it with the telecommunications costs, but we haven't talked about the details of how that would actually happen. Now, one way to reduce these enormous costs is to put these in when buildings are under construction. And Tony, our next speaker, will talk about that a little bit in a new project they're doing at NREL. So they're doing a better way, do it from scratch. But a lot of the buildings we're going to be retrofitting our existing buildings, and we have to deal with that cost as well. I pointed out the agreement among the contractors on this cost, which was certainly encouraging. And the peculiarity of this particular project might have to do with what the capacity on the building is right now. And as we get into those big DC charging levels, we're talking about adding some significant electrical service. But even with that, the percentage of the total cost is small. It's putting the conduit in, core drilling through these concrete floors, putting in the electrical room and so forth. It's expensive in addition to what the utility does. Okay? So this is what we came away with. And those of you that have been coming to this SMS for several years know that I was concerned, as was Dr. Wells a long time ago, about the fact that the US government went down the ethanol road. And we warned that that might not be the best thing to do. And now I have to alert you to the fact that if we're going to do electric vehicles, we may as well use real costs instead of the kind of optimistic costs we might read in this or that report. It's easy to go out, get a bid, use the right number. Okay, so my presentation will be on this website, or you can email me for more details. Thank you.